Hey guys, it's Mr. McNeil. I'm going to work through a couple other examples of solving rational equations, similar to the ones you did in the MVP video, except with a slightly different way of doing it, so you can see another method. So here we have the equation 4 over x plus 1 over x squared equals 1 over 5x squared. And so what I want to do is, just like when I'm adding any other fraction, I want to find a way to make all of these denominators the same, so find a common denominator. And to do that, what I'm going to do is find what am I missing in each of these in order to make them all the same. So I'm going to say that the least common multiple of all three of these is 5x squared. So I need them all to be ultimately 5x squared in the denominator. So what can I multiply this denominator by to get 5x squared? So if I have x, I'm going to need to multiply by 5x, and that should give me 5x squared. But if I do that on the bottom, I also want to do that on the top. So I'm going to multiply the top and the bottom by 5x in order to get 5x squared in the denominator. So if I rewrite that, I can multiply it out. So 4 times 5x gives me 20x over 5x times x gives me 5x squared. Now for this second term, what I want to do is, again, what can I multiply the bottom by to get me to 5x squared? So I already have x squared, so I only need to multiply by 5 in this case. So I'm going to multiply the top and the bottom, by 5. So now when I add this next term, I'm going to do 5 times 1, which is 5 in the numerator, and then 5 times x squared, which is 5x squared in the denominator. And then my third term is just going to stay like it already is because I already have 5x squared in the denominator, so that's what I need. So now I have the same denominator for all three of these fractions. So essentially, no matter what number I put in for x here, all of these are going to end up being the same. So all I need to do is find the x value that satisfies this top part of the equation, or the numerators. And so to solve for that, I am going to ignore the denominators again because they're all the same. So I can just rewrite this equation as 20x plus 5 equals 1. And then I'm going to subtract 5 from both sides. Remember, my goal is to get x by itself. And now I want to divide both sides by 20. And so that will give me x equals negative 4 over 20, or if I want to simplify this, 4 goes into 20 5 times, so I could simplify this as negative 1 over 5. So that would be the x value that satisfies this equation up here. All right, so another way of solving the same problem, so let's go back and just look at what the problem was. So we had 4 over x plus 1 over x squared equals 1 over 5x squared. You could also use Desmos to graph this. And so remember, when we're graphing these in Desmos, what we want to do is graph the left side of the equation, and then separately in another graph the right side of the equation. And then we want to find where they intersect. So the red graph here is the 4 over x plus 1 over x squared, the left side of the equation. So that's going to give me the red graph, and then the 1 over 5x squared gives me the blue graph. And so if I click on either one of them, it should show me this point here where they intersect. So they intersect, according to Desmos, at negative 0.2 comma 5. And remember, negative 0.2 is the same thing as negative 1/5. So that confirms our answer and also shows you a different way of solving the same problem. All right, let's try one more example. This one's a little bit more complicated, but not too bad still. So anytime that I have a trinomial or something like this in the denominator that looks factorable, I want to go ahead and factor it first, and that's what I'm going to do here. So I have x squared minus 2x minus 3 in the denominator of this fraction, and I'm going to go ahead and factor that. So let me rewrite the whole thing. So 5 over x plus 1 stays the same. And then 6. So I need two numbers that multiply to give me negative 3 and add to give me negative 2. So that's going to be x minus 3 times x plus 1. So this is equivalent to this. And then we have the last term is going to stay the same. I can't factor x minus 3, so that stays the same. All right, so now it's a little bit easier to see what I'm missing in order to make all of these denominators the same. Remember, that's our goal, is to get a common denominator between all three fractions. So for this first fraction here, I'm missing an x minus 3. So in order to get all of these fractions to have the same denominator, which in this case I want all of them to have this denominator here, x minus 3 times x plus 1. So in order to do that, I'm going to multiply this first one by x minus 3 in the top and bottom. Okay, so when I do that, let's go ahead and talk about actually what I want to multiply this one by. So if I want to get x minus 3 times x plus 1 on the bottom, on this side, I'm going to multiply, oops, sorry. That'll work. Oh, no, it won't. Here we go. Multiply by x plus 1 on the top and the bottom. That's all I'm missing in this fraction in order to get the bottom to be x minus 3 times x plus 1. So I did a lot there. Let me rewrite all of this. So when I multiply x minus 3 times 5, I'm not going to distribute that just yet. So I'm just going to leave it as 5 times x minus 3. And then the bottom will be x minus 3 times x plus 1. So that's going to be equal to, I didn't do anything to this middle fraction, so that all is going to stay the same. It already had everything I needed in the bottom. Whoops. And then here, when I multiply 1 by x plus 1, I'm just going to get x plus 1 in the top. And in the bottom, I'm going to get x minus 3 times x plus 1 again. And so you already know where we're going with this, and you could probably do this in fewer steps, but I wanted to show you how I do it all the way through. So now that all the denominators are the same, I'm going to essentially ignore them. You could also think about it as multiplying the whole thing by x minus 3 times x plus 1, and essentially canceling out. So I would distribute this here into each term, and that would essentially cancel out the denominators. Or you could think about it, like I said, as no matter what value of x I put in here, all of these are always going to be equal. So I only have to find the x values that satisfy the equation in the numerators. Either way you think about it, what I'm going to end up getting is 5 times x minus 3, in parentheses still, is equal to 6 plus x plus 1. And so let me scroll down a little bit. So I'm going to go ahead and distribute this out now. So 5 times x minus 5 times 3, which is 15, equals 6 plus x plus 1. Now I want to combine my like terms. So on this side, I'm going to keep this like it is for one extra step and combine my 6 and my 1. So I've got x plus 7 on this side now. And now I'm going to combine like terms across the equal sign. So I'll subtract x from both sides, so that'll give me 4x, and then I'll add 15 to both sides. So 7 plus 15 should give me 22, and so if I divide both sides by 4 to get x by itself, I should get x equals 22 over 4, or I could simplify this to be 11 over 2. So 11 over 2 is the x value that satisfies this original equation all the way up here. So if I plugged in x equals 11 over 2, I would get these two sides of the equation would be equal. And last but not least, again, just if you wanted to solve this using Desmos instead of algebraically, you would graph each side of the equation separately. So I'd graph this side and I'd graph this side, and then I would find where they intersect each other. And so, when I go into Desmos, I already typed the equations out, so I'm going to turn the graphs on. So the red graph is going to be the right side of the equation from before, so this red line, and then the blue graph will be the left side. And so I want to find where they intersect. So sometimes you might have to look around a little bit. It's not always going to be immediately obvious. Since we did it algebraically, I know it should be right around 11 divided by 2, which is in fact 5.5. So 11 divided by 2 is the same thing as 5.5. So that just verifies my answer and shows you, again, another way of figuring it out.